So we're jumping ahead here. We do want to hit file access, even though it's not on the straight allotment of homework that I've laid out for y'all for this semester. But I think we need to hit it anyways. You always have to know how to do file access. And it hits topics that I do not think that we have not covered yet that are essential, which you probably have hit in other languages such as Java, such as exception handling. So we are going to jump to chapter 14. We pretty much know what a file is. I can skip this slide, right? A file is a form of permanent storage, right? You turn your computer off, your programs lose their data. But if they've been saved to a file, then no, that data has not been lost. And nowadays, the data can be saved to the so-called cloud rather than to the disk. But, you know, be that as it may, we're going to talk about disk files. So, typically we talk about bytes. A byte holding one character, well, that's not strictly true anymore since Unicode is a multi-byte character set, right? So that to write out the word hello with 5 letters in it is probably going to take 10 bytes. But anyways, we talk about bytes, which are 8 bits. We talk about kilobytes, which are effectively 1,000 bytes. It's actually 1024. And then megabytes, which are 1024, kilobytes, which is a million bytes, and then a billion bytes, and so on. So, text files. Text files contain information in ASCII or Unicode characters. And we talk about text file editors like Notepad. And Visual Studio, our source code, is stored in text files. I believe they're in ASCII format, but that makes me wonder if they could accept Unicode, notation or not. I bet you can have a Unicode source file as well. Otherwise, how are you going to type in Unicode strings, display strings in Turkish or whatever. And then there are binary files. Binary files are the files which contain, like image data, right? Those are the files where if you pulled them up with a text editor, they would look like, they would not be comprehensible, right? So if I go somewhere and I do Notepad, and I type some text in, I'm going to see, right, then later on, when I come back and edit it again, or I display it, there we go. Hello, that's ASCII text. Hopefully you've had the idea of ASCII by now. But you go somewhere else. Do we even have any music files in these guys? Do we have any pictures? Probably not. All right. See program files. All right, so pick any one of these. We're going to see executables, which are obviously not going to be in ASCII format. Right. If we edit it in Notepad, we wouldn't be able to comprehend what we were seeing. So it takes a slightly different approach to write a binary file than an ASCII file. Quite often, you can pick what you want to do, right? You can store numeric data as a text file, right? You could just store those numbers, right? You're trying to store the number 256. You open it up, you see 256 in that file. Or it could be written out in some form of binary, in which case the representation of it would be completely different, whether that 256 was stored as a float or as an int, right? And as an int, it'd probably be stored as FF. No, sorry, 100, because that's the hexadecimal equivalent of 256. Anyways, so you usually get to pick what format, but there are some things that lend themselves dramatically towards a binary format. You would not want to convert an image to any form of text format in order to, to store it, right? Because an image is just pure bitmap data. Same for MP3s, right? It'd be an extraordinary waste of space to try to convert that to some kind of text file. So you have the ability to write to the file and read from the file. Typically, the classes that create binary files and the classes that create text files are different because they have different goals in mind. All right, this is just standard computer usage. You know what your root directory is. And, PC's C:, right, is your root directory. And on Macs, in Unix, it's \, right? And then you have subdirectories, subfolders. And then you have a path that lists the root directory and then a list of all the folders or subdirectories, and then finally a file name. And when you open a file from within a programming language, you can usually get away with just specifying the file name. If you do that, it's going to try to open the file in whatever current working directory you're in, which is often the directory that the executable is in. And often you do not want to create a file in that directory, right? If your program was installed on a, in a production basis, then the application directories might be all right protected. You wouldn't want to be creating your text files or your temporary files there. So C# provides built-in classes for named file and directory. Contains methods to help you manipulate the files. You can get the access about information about the files. You can create, delete, or move the files. Let's Google up C# file class example, just to jump into the fastest. And this is what I was expecting us to be able to hit, would be classes. And I would expect that these are all derived from the file class. Things like binary reader, binary writer. We get the idea for what these things are going to do just based on the names. You want to write some data out to a file, you use a binary writer. You want to read data in from a file, you'd use a binary reader, and so on. So the file stream class. We've heard the term stream in C++. Typically, a stream can be used not only for file access, but for communication across the internet. And so I'd expect that there are some associated classes which are implemented for reading and writing across sockets, as well as file I/O, which would work with very similar method calls. So if we're going to create a new file stream, that would be the name of our class, file stream. You specify the file, you specify the mode that you're going to open it. I want to be able to open it I want to be able to read. That makes sense to me. We're going to be opening it for access read and for sharing read. So different file modes. If you want to append to a file, it would open an existing file. Create the file. Create a new file. It's supposed to wipe out the file. Now to me, those seem synonymous or whatever. Open would create an existing, opening an existing file and fail. Open or create. Seems like there are a lot of different varieties here, but typically, those are the ones that you need to be concerned about. Like, what if you want to open a file but wipe it out? There's the mode with which you can do that. What if you want to try to open a file and if it does not exist, have it gracefully created? Well, there's a method for that. Not a method, yeah, a mode for that. What if you want to open the file but fail if it doesn't exist? Like that. Those two are still nebulous to me. So an example of using the file stream class. We're going to create a file called test.dat. We want to open or create it, so if it doesn't exist, it will be created. And we're going to open it for reading or writing. So here's what we do. We're going to write 20 bytes to it. This is pretty much binary data, right? Because we're telling it to write out bytes. We're not telling it to write out text. So we could specify any form of binary data that we wanted to. Then we're going to reset our position back to the beginning of the file so that we can read those bytes back out. Let's go back to PowerPoint. So using the file into directory classes, slightly different approach. This is looks a little more crude to my eyes, but it looks equally useful. You're going to create a file, then you call create. You want to create a text file, you call file.createText. Want to delete a file? That looks more like a directory access combination. I want to see the code examples. Alrighty. So we ask them for a file name. We use readline to get the file name. We check to see if the file exists using the file class. Using a class member of the file class, we did not instantiate a file in order to do that. And then we get all of that information out of the file, right? If the file existed, we can pull out its creation time, it's the last time it was accessed, and the last time, it was written to. And then the directory class. Create a directory, delete a directory, whether it exists or not. Get files, get a list as a string array that contains all the names of the files in the specified directory. That one might be fun to play with, just to get things going. So I'm going to load up Visual Studio, create a new console app project. Here we go. I was getting an error because we were trying to create a file in a read-only directory. Obviously, that's not going to work for us.
Is this W or does it matter?
I think we already have lectures W all the way mapped out. Let's go see what we ought to call it. Z1, Z2, Z3. Let's go look. Oh, I guess we really are. Yeah, we're W, so it'd be X. We're on assignment Edge. X.
So W was from the previous semester.
Right. The lectures that I posted here are based on videos recorded from the last semester. And some of them cover stuff. For example, W is a review pretty much of material that we've already covered, kind of snuck them in to in our prior lectures that we gave this semester. All right, go take a peek at our code here. We're not going to ask for a directory name. I think we ought to try to create a directory. But let's get all the files from the current directory. And in pretty much every operating system I've ever seen, you can use the period as an alias for your current working directory. So let's do that. String dir name equals double quote period double quote. Then we're going to do if directory.exists dir name, and it sure had better. We had better have a current working directory. So if directory.exists, now I'm getting an error about the directory class not being used. So we would need to bring in system.io. So we're going to add using system.io to the top of our file. Hope it's not a package I have to bring in. System.io, there we go. IO's in caps. Do I really have to type out the whole name? It's just, oh well, I didn't put parentheses for one thing, did I not? All right, excuse my Python lapse there. So directory dot exists, and we're going to pass in our dir name as our option there. console.out.write line placeholder 0 exists, or placeholder directory exists. Whoopsie, and after the quote, comma, dir name. I'm not going to even add an else clause, I oughta, because I'm fully expecting that directory to exist. I did not add a read key to the end of it, so it's going to open and close magically fast. Yeah, okay. So at the end of main, of course, console.read key. All right, so that directory exists. What other information can we get out of that? I'm just going to type directory dot to get a list of members. Get the creation time, that's kind of fun. Get the current directory. See, that's of interest to me because we might be able to get a better path than just dot to indicate where we are. So we're going to need to see what that returns. It returns a string, okay? So string CWD for current working directory is equal to directory.get current directory parentheses and parentheses, like that. And let's print that out. Console.out.write line parentheses CWD. And that's our directory. C users / all the way out to bin / debug. Could we change our current working directory? Yeah, clearly we can, right?
So if you were to export this to another computer, and let's say it's on a desktop, and you want your file to save directly to the desktop, you could just say save to a string that saves in the current directory.
Right.
Okay.
Right. If you have this, application installed somewhere else, you're not going to always, be running this stuff from the, from the Visual Studio environment. Then whatever the current working directory is where the .exe would be, and you would not want to store your data there. And the Windows operating system provides aliases so that you can specify, oh, I want to write this one to the user's documents folder, stuff like that. That'd be quick. Let's click get documents folder path C#. So environment.get folder path would be the way to do that. There ought to be an easier way to do that. Path.combine, environment, expand environment variables. Hopefully you know what an environment variable is. And at this point we're learning Windows specific programming, which is fine because that's what C# is generally designed to do. Of course, there are now, C# implementations for other operating systems as well. But the environment variable, we should have an environment variable called user profile in Windows. So if I go to the command prompt and I type set, then there should be one called user profile. And so when I get the user profile, it's going to have a path, C:users : /JG Thompson. If we look at the other environment variables, we'll see, okay, my program data is supposed to be stored there. My program files are supposed to be stored in C:program files. And my 8-bit program files, my x86 ones, ought to be stored in that program's file directory. And the system drive is C, the system root is C:\window, and here's my temp directory. Say you want to create a temp directory. Well, you could use that environment variable in order to create our temporary directory. I think that would be a fun one to go ahead and play with. So I want to expand, I want to get the value of this environment variable so that I can then append a file name to it. And our little Microsoft page here shows us how to do that. We're going to use the environment class in order to do that. I'm hoping that's also part of system.io. Let's find out. Go back here. And so string, tempdir, T-M-P-D-I-R equals environment. I want to make sure I get it right so I don't fumble it. Dot expand environment variables. Environment dot expand environment variables. Let's go look up other examples of that. This one's talking about a difference between the what that function returns if you're on Linux rather than you're on Windows, alluding to the fact that you can write, applications for more than one platform. I'm not seeing like a cute list of useful environment variables. Common program files is one, Anyways, not seeing what I was hoping for, so we're just going to go with it. And percent, and the environment variable that we want is, when I typed set, I saw one called TMP, and it was also, echoed by one called TEMP.
There's no one for documents?
Pardon me?
There's not one for documents?
Yeah, I was hoping to see that. But like I said, there are aliases that Windows provides that'll do the same thing. So it's not set as an environment variable, but there's an alias that will lead to it. And so we will look that one up in just a second as well. Get asked. Yeah, you too. Okay, so we're back here, and the environment variable that I want to look up is just going to be percent TMP percent. Maybe in caps. Looked like they were all in caps, did it not? I went in pretty sure that it would work either way, but why not match it? Because I do see some that are uppercase and lowercase specific. But, I mean, we could try it out. We could try it out both ways. All right, let's print out our temp directory. Console.out.writeline tempdir. I'm just in a hurry to see what it is before we actually try to run it. Or I could just get an error. Oh, I had two closing. Excuse me. Only one closing parentheses there. All right, and what do you know? So there's my temporary directory. Notice that it's returning it in a somewhat what I would call mangled format, meaning that when DOS was originally created, in the 70s, and it inherited from CPM the limit that directory names, folder names, could only be 8 characters long. Obviously, you can have folder names that are longer than 8 characters now, but the operating system is returning an 8-character version of that directory name right there. And I bet that there's a switch that you could use that would tell it not to return the 8-character limited version, but the entire one. But the operating system interchangeably uses those. If you typed in CD followed by that path, it'll take you to the temp directory, but then if you, we can prove that. Come back here. Why did that close that? I'm just going to copy that, go back to my command prompt, CD into that. I'm going to put quotes around it, even though I don't need to. You have to put quotes around it if it had spaces in it. But in this case, it doesn't have any spaces in it. Well, dir/s/b means giving me a listing of all the files and all the subdirectories in a blank format. It's showing me the 8-character limit, but when we looked up here, it was not like that. Oh yes, it was. That's why we're getting it. All right. Sorry to go off on that diversion. If you do dir/?, we should see a way to specify that we don't want the short version of the directory names. dir/s/n. Now, not finding it, not gonna spend any more time on it. All right, so we could create a new directory, a new file name based on that environment variable, right? File, or string outfile is equal to, and this isn't the best way to do it. We saw the syntax for the best way to do it on that Microsoft help page. Tip_dir plus a slash plus the file name that we want.
Before your quotes, you can just write it all out.
Right. Now the difficulty in doing that is that not every directory uses a slash as the separator.
Yeah,
at one time, Max used that, for example. So there is a function call that will build a path for you based out of the various components, and it will be formatted correctly for the operating system that you are using, which is path.combine, where you specify a path and then a file name, and it will build an appropriate, an operating system precise. Now, usually they're interchangeable. Usually the operating system will accept calls using forward slashes and backslashes and all those various different types. But I'm going to try to make this as correct as possible. So what we're going to do is we're going to use path.combine, and then we're going to pass in our tempdir. So path.combine tempdir, comma, and then the file name that we want, outfile.txt, and quote. And let's write that out. console.out.writeline tempdir. Nope, outfile. Hope y'all can see that. I don't know how you guys do this without having two monitors on your screen, one for the video and one for the editor. So you laptop users, I don't know how you do it.
At home, I have two monitors.
Yeah. All right, so that is a fully qualified path to a file. Fully qualified meaning that there's no dots or dots. Just like I said, a dot means the current working directory. Dot means one level up. So like if I do dir dot, it gives me a list of all the files in my current working directory. But if I do dir dot, it lists all the files in one directory up. Now some operating systems made it where dot meant two directories up and so on. But Windows, no. But you could do dot slash dot or dot slash back dot, and it would go up two levels. And you could keep appending those. But those are relative directories, right? You can also move up directories when you're in the command prompt or terminal doing the same thing. Like that. All right, what can we do now that we have a cool file name? File dot. We could create a file. We could delete a file. We could check to see if it exists. Let's check to see if the file exists. So if parentheses file dot exists, and specify our outfile. What was the abbreviation for?
CW_tab.
There we go. Yeah, CW_tab, console.writeline. Let's just write out the file name, outfile plus C string, space exists. And then I'm going to copy and paste that and put it into an else. I could just return the value, the Boolean value, and print the the Boolean value rather than do all that. I forgot to make it say not exist. All right. Or does not exist. There we go. Outfile.txt exists. Well, that is interesting news to me. I honestly was not expecting that file to exist.
Did you do that backwards?
Did I? Yes, I did. Yes, I did. Good catch. Good catch. I edited the wrong one.
I made the same mistake for
All right. It exists and does not exist. We're going to create that file. I'm just going to go to the operating system. You don't have to do this. Why do we create the file programmatically just so that we know that it exists? Why don't we go back to doing this a little bit? Oh, we didn't play with list of files yet, where we get the list of the files based on the directory. Let's get a list of all the files in the temporary directory. So, list of files is going to be an array. Notice that we are not actually specifying the size of the files. It's just an array reference at that point. This function returns the array allocated out to the correct length. And I could say that that implies something about the way C# does it. We've already mentioned before that everything is a class in C#, including arrays. So it's reasonable to expect that an array can return the length, of the elements in it, whereas in C++ it does not do that. That's the way Java works as well. Not everything is a class. Primitive data is not, but the arrays certainly are. Right, so string, I'm going to get this right. Yeah, string square brackets, files is equal to directory dot get files, parentheses, and we're going to specify our temporary directory, tmpdir. Whoa. tmpdir without all that excess junk. And now we could use a for loop to display that stuff, right? For every string s, for each, sorry, too much Java in the brain. For each string s in files, cw tab, so console.outWrite line file equals space end quote plus s. And there we go. There's a listing of all the files that are in that directory. So what could you do with that? You could pop it up, in a menu. What if there were thousands of files in it? It might not be such a good idea. Right. Let the user pick the file that they want to open. You've seen file directory, the components that Windows uses to pop up a directory listing of files so that you can select one. That'd be a good thing to do too. There's so much I want to do. That falls under the Windows programming, which is a class that we need to offer again. So we have a list of files here. Who knows what they are, but why don't we just arbitrarily, I'm going to assume that you have stuff in your current work, in your temp directory. So I'm going to do string fname is equal to file subscript 0, right? I'm just going to get the first entry out so that I can play with it. I want to find out some information about that file. So file dot get access control that returns a class, it returns an object. So I'm not going to mess with that. How about get attributes? Get attributes also returns a class called file attributes. what kind of attributes do we mean? Well, like whether an object is read-only or not. That might be fun to play with. And then this will be kind of the last thing that we do on this little diversion before we go back and hit the PowerPoint again. So I'm going to do file attributes fab is equal to file.get attributes parentheses fname. And the first thing I'm going to do is just out of pure curiosity is to print FAB. Without even knowing what those are, I'm wondering if they have a nice string representation when we try to print them out. So CW tab console.writeLine FAB. I'm not seeing that I see anything in particular. I didn't expect that to work, actually. But I had some vague hopes. Attributes is equal to archive. All right. We better look up to see what kind of attributes we can pull out. What kind of attributes there are. So I could type fab dot. Yeah. Change is not allowed while application is running. All right. So fab dot toString. That's the only attribute. All right. Got to Google that up. File attributes, or not Google it, highlight it, hit F1, pull up the documentation for it. All right, so it's an enum. Whether it's archived, it's a candidate for backup or removal. Whether it's compressed, reserved for future use. Whether the file is a directory, and yeah, that's how these things get nested, right? Each directory you see also, is considered a file, but it's considered a file of a completely different sort. It's a directory entry. Whether the file is encrypted, whether it's hidden, and yeah, files can be hidden from the operating system. Hopefully you're familiar with that type idea. If I do dir/ah, it means the attributes hidden, and it should list. I may not have any hidden files in here. Doesn't list any. Okay, there's something called t.txt that it came up with. Really? That's hidden? All right, I'm messing up on the dir/ah star.star. There's all of our hidden files. So if I do a lookup on ntuser.ini, if I type in that, dir ntuser.ini, don't see it. Unless I say /ah. So I'm going to change that file name to ntuser.ini temporarily, just because I want to see what attributes it pops up when I do that. So I'm going to come up here, and where I created my file name and I called it output.txt, instead it's going to be ntuser.ini. I'm sure I will change it back, ntuser.ini, and then I'm going to run it. It should tell me that the file exists, or I could get a build error because I left that dot there down on FAB. All right, ntuser.ini does not exist. Well, that's a surprise to me. I thought we saw it. I'm in the wrong directory. I'm now in just my JG Thompson. I forgot to. I need to go into app data local temp. Fine. If you were following along exactly, sorry about that. You may not. Okay. App data local temp. Now dir/ah. None of them are hidden. Well, I could mark one of them as hidden. You use the attrib command. You use chmod in Linux. I'm going to forget that. I'm not going to mess with that anymore. I'm going to go back and change my file name to something that I really want it to be. Outfile.txt. All right, so we've seen how we can probe the operating system for information about a file. That scratches the surface, right? But hopefully, you get the idea that you can go in and dig deeper on that concept. Don't care about the data hierarchy. Don't care about fields versus records. So C# app opens a file by creating an object and associating a stream of bytes with that object. So yeah, you could read to it, or read from it, or write to it. As soon as you're done with the file, you should always close it, because if you leave it open, the operating system may keep it locked in some format that it could not be copied to another directory, or that a second application couldn't access it. Right, a backup program may not be able to hit it. Not closing a file may make it inaccessible for the duration, that your program is running. It can also result in the data not being written to the file. You're never sure that everything has been totally flushed to the operating system until you close it, although usually there's like a .flush method that will, it'll ask the operating system to save everything to it. And why would we do that? Because you've heard of file caching, right? Where you do a read and it stores some data into a place in memory so that data can be accessed more quickly and not have to hit the operating system every single time you want to read something from the file. Well, the same thing happens for writing to a file. When you issue a write, it doesn't immediately show up, on the magnetic bits of the disk itself. It's, hanging around in the operating system waiting to be committed to disk. So default stream objects in C#. We've been using console.in and console.out the whole time. However, you can create a file stream where you can still do .write, right, and add to the file, except you'll be writing to a file stream rather than a console in or console out. Most streams flow in only one direction. Our stream classes could be stream reader for reading text from a file. Same idea as using a scanner to read from a text file in Java. Stream writer to write that file out. And then a file stream. File stream would be for bytes, which would be for a binary file. File stream properties. Can we read? Can we seek in it? Can we write? Can we set our position? I am hungry for an example. All right, here we go. Here's our example. File stream is outfile is equal to new file stream, and then we create the file. We list our attributes. We want to create the file, and then we want to write to the file. That sounds like a good thing to do. Let's create our outfile using our directory, our fname. So file stream fs for file stream out is equal to new file stream. I'm going to specify our file name, which was fname, comma, and we need to list our attributes. File mode.create and file access.write. So file mode.create. How about open or create? I don't know. Yeah, if the file already exists. Okay. So file mode.open or create, comma, file access.write. We want to be able to write to it. Now we're going to write some text to it. So we're going to use, they used a stream writer to encapsulate the file stream. That concept may be familiar to you from Java as well, where you create a file object and then you create a wrapper, or you use a wrapper that gives you access to the methods that write to it. So stream writer SW out equals new stream writer, passing in our file stream fs out. And we seem to be doing precious little error handling at this point. And SW out dot write line quote, this is a file. Then we're going to need to close our stuff, right? SW out dot close parentheses and parentheses, and then FS out dot close. Now, when things fall out of scope in this language or in Java, then the destructor is called automatically, and so dot close would be called automatically. But there's no reason to wait for something to fall out of scope in order to close the file. All right, gonna run it.
I believe that if you don't put the close method, you won't be able to access it later. I think if you're using what's called a using statement, it automatically closes it. But that, because I've gotten lots of errors not putting the close statement in.
Okay. Well, I forgot to write a message, you know. But if I go back and I go back to my temporary directory, and I really wish I hadn't changed, you know, close my console in order to do that. Set, and my temp directory is that, so I'm just going to copy that. Mark. So that I can CD into it. Why don't I get into it using Windows rather than a command prompt. All right, now I should be able to find my new text file. I'm going to sort by date modified. Make sure a lot of directories there. I'm not seeing my file. Out file. Nope, not seeing it at all. What have I done? Dumb. Well, I guess I will go look at it with my good old terminal here, command prompt. dir/od, meaning ordered by date. Well, I see something that was created there, but I don't see my .out file. Well, that's interesting. Why don't I go back and look at the PowerPoint? The error occurs if the next two statements are reversed. Well, that makes sense because we created our stream writer after we created the out file. What can I read from the file? I'm not seeing it reflected in the operating system. So,
is it because you made file access write only? Could that be why?
all right, please repeat the suggestion.
The file access, file.access is write.
Yeah.
So if it's write only, then maybe we can't read it.
Well, what did they use in their sample example?
Read write, I see as an option.
Sure, I can change it to .read write. Their example didn't have that. I'm going to change my example to exactly what they have at first. which is .create, then .write. But if it wasn't able to create it, we should be getting an error message. Why don't we do this? CW, tab, quote, placeholder 0, written to, end quote, comma. And I'm curious if what all we get from fsout. So I'm going to type fsout dot. Can it kick out the file name itself? Yeah, dot name. All right. So console write line, placeholder 0, written to, end quote, comma, fsout dot name, and it's actually a property, not a method, so no open close parentheses. That can't be the error. How odd. All the errors are now referring to if I mangled that. How did I mangle that? Close solution. Open recent project. Rebuild solution. Well, how in the world did that get modified? Copy the entirety of main. You should not be having to do this. Are you having to do any of this? Are you getting build errors of this format?
Yes, but only because I've changed my path to my desktop.
Okay.
So then it tried to get the attribute for something that didn't exist.
All right, so I'm going to create a new console application. I'm going to go in and replace the main with my current code. The name directory does not exist in the current context. Oh, that's because I have not included system.io, so using system.io. Rebuild solution. Well, what did I do wrong? This is code generating. It seems like that's about the only thing I added was that line there. All right, I'm going to pause the recording until I figure out what's going on. All right, gang, I'm pretty sure you did not get that error. And I hope you didn't, because it completely broke Visual Studio for me. I could not create a project that would work. And I wish I could show you the change that I made that fixed it. But it did not have anything to do, as far as I know, with this program file. So I hope yours is not in the same state that mine was in. I think that I ran off the rails somehow. Okay, so I'm going to go ahead and run this now. This is the code before I started creating new projects and copying and pasting and stuff like that. All right. Oh, look at that. that is purely my mistake and my stupidity. I actually did corrupt a file. And how did I do that? I have this cute directory listing, right? And then I set the file that I wanted to open equal to the first one, the first file.
So did you write over it? Is that what you
And
did?
so I overwrote it.
Yeah.
Correct. So now when I try to build it again, you're going to see the error again. And if you were following my stuff exactly and running it every time I did, you may have gotten to the same corrupted point. And I apologize for that. I guess I need to put a warning when I upload the lecture. Okay, so here's how I fixed it. I clicked on the top error, and ooh, it's completely empty. Anyways, the text that I wrote to it that was wrong was this is a file. I overwrote that file. I wonder if I could just delete that file. But anyways, because it's a temporary directory, right? You ought to be able to delete everything in the directory. But I backed up over that. And then if I come back and I try to build my program.cs again, it ought to build cleanly. And it did. So my stupidity on my part was when I returned a directory from the file listing here, and I said fname is equal to file 0. That was dumb. I thought I built a path to my file. Yeah, outfile. That's really what I wanted to be using here. So that's a real drag because I messed y'all up. Anyways, you saw how to correct it. You could just go into the temporary directory if you actually have been following along, making every change that I have. I don't want to do this here. I don't want to do string fname is equal to file 0. I've already created a good file name up here called outfile. So outfile. String fname is equal to outfile. Yeah, somehow I need to edit the video to put a big warning comment. You know, as soon as I type that, don't do this, type this. So I'm going to have to edit the YouTube video. Make sure you don't run it in the same state I did. All right, now when I run it, it is going to create the file. I say that. Well, I'm going to set a breakpoint and then step through it. Right there. So debug, start debugging. Call stack, I'm currently on line 37, which is my breakpoint. I'm going to do step over a couple of times. Exception unhandled. Cannot get file attributes for that file because the file doesn't exist. So I'm going to comment that line out as well. I'm going to comment out the file attributes line. I'm going to comment out the console.write line. Stop my debugging. I should move these inside the if statement that checks to see if the file exists. I need to remove my breakpoint. Need to run it again. All right, and there's what I was ultimately hoping to see. Outfile.txt written to. If I go back to my console, I do dir/od, I'll see my outfile.txt. If I notepad it, or if I went into Windows Explorer and double-clicked on the file, there, I've created a text file. I'm pretty happy with that. I'm sorry that I went off the rails there. I'm going to have to be real careful.